Let's review some more. So first of all, let's start with good practices. So, for class names, again, you should start with a capital letter. And you can include numbers and lowercase letters and capital letters and underscores and stuff like that. But it's generally advised in Java that you start with a capital letter, not a lowercase letter. And of course, you can't start with a number. So start with a capital letter, then for each word, you start with a capital letter as well. So review part 2 would be like that. Now, of course, we define this in review2.java, so we have to make this class review2. Another thing to note, it's probably good to type the opening bracket and closing bracket before typing anything that's inside, because think about it. If I just start, I could forget to finish. And plus, another thing is this just gets messy, like in general. How do I know where to put the brackets? This is extremely disorganized, so therefore you should probably put the brackets together so that way you get to put everything inside the brackets without worrying about brackets at all. Next, so variable names. So first of all, they should start with a lowercase letter, and then for every other word, like for every word after that, it should be a capital letter. So variable number, for example, here. And then constants basically should actually be all caps, and then have a word separated by underscores, like that. And that way it's super easy to identify whether or not something is a variable or a constant. And typically, actually, variables are private or at least not public, and then constants are public. And more examples of constants are math.py. Notice this thing is the all caps math.e, integer.max value, integer.min value. As you see, the constants are all in caps and separate words are separated by underscores. This is different from normal variables where they're mostly lowercase, except start of every non-first word is capital. Some people instead use underscores to separate their words, but that's a different story. So method names, same thing as variable names. So for example, pointless, and then method starts with a capital. And notice again, we put our brackets first. Back to the variables. So static variables, again, variables that belong to the class, we do not need an object. However, instance variables require an object. So class A, basically if we have that, then we need a new object before we can do anything. Now, similarly, if you accidentally say make a instance variable inside of our main class, then if I try to do anything with it, it won't work because we need an object. Again, we need a review to object. So either do it this way, but that's really pointless because we're not going to be able to access the object anyway. Or if you really want to access it, basically create a variable and then review to variable and then r1 dot useless variable equals 9. Of course, this is not advised. You should put instance variables when you actually need an object, like for example length in rectangle, not stuff like this. Over to methods. Again, static methods are methods or functions or actions of the basically class itself. We do not need an object. And again, methods, we can have void or we can have a return type. So if it's void, then you don't have to return anything. You could return, but you can't return anything. Return basically just quits the method. You can't return a value. And you can also put parameters, and they can be separated by commas. Remember that we cannot have two methods with the same name and same parameter types in the same order and in the same class. Again, instance methods are like methods that require an object, so like the area method in rectangle. Again, return types basically means once you have a return type, you need to return. So like, for example, return 0. Now onto constructors. Remember, constructors are always instance, so you can't have public static A. That ruins the point of a constructor, which is to construct an object. So therefore, constructors are always instance. Now let's go over this example. So first of all, what are the instance variables? Well, it turns out ARR and size are both instance variables. One is public and it can be seen to other classes, while one is private. However, they're both instance variables, which means we both need a dynamic int array object. And now, which one is a constructor? This thing's a constructor. And notice that capacity is a parameter. It's not like an instance variable or anything like that. You can't access it outside the constructor. And then what about instance methods? Add and remove. Again, no static keyword, so you need a dynamic int array object. Static variables, there's none here. And static methods, there's none here because you see there's no static anywhere here. So now, first, what does this class do? Well, we store an array and we store a size. And we see that when we construct a dynamic int array with a capacity, it sets the array to an array of that capacity size. So then when we add, we just add an element to the array, increase the so-called size, where the size starts at 0. So what that does is basically, this is basically a growing or shrinking, because remove method, array, except it has a capacity. And now, for example, dynamic int array so something like that. Again, we need a new keyword to construct an object. And then, for example, d1.add 7, d1.add 9. So this print statement would print 9. Now, I made the ARR variable accessible to every other class. I could have easily made it private and then put get and set methods. That would work as well. Now, what about the size variable? Why did I make it private? Well, it turns out here, the size variable is meant to represent like where I should insert the elements into the array, and basically like what the current array size, or technically the array size is the capacity, but like how many slots we're using. If we just randomly change d1.size equals 5, that just screws up our entire array, and now we'll be adding elements starting from index 5. And plus we'll hit the bounds prematurely. If I instead do d1.size equals 0, all of a sudden, now when I call the add method, I'm overwriting the numbers I've already put into the array. So therefore, I made this size variable private so that they can't freely modify it and screw up the array. And of course, these methods should be public because they're meant to be used. So again, I could say make this thing private. Ignore that print statement for now. Make get and set methods. And again, get methods return stuff, but set methods don't usually. And then if I want to access the array now, I can just do like d1.get 1, and it would work. So usually, again, variables, instance or static variables are usually private because you usually don't want them to modify it. If you want them to access it, you could always provide methods for them to do that. But usually you don't want them to modify stuff. Usually methods, instance and static methods are usually public because they're meant to be used. You can have some private helper methods, basically methods that like other methods use, but you don't want to be accessible to the public because it could be used in a twisted way. So yeah, and usually public instance variables, if you're like programming just for yourself, it doesn't really matter. But if you're programming for like other people, it might be useful to just make all the instance variables private and static variables, because usually you can just provide methods to get them, and it's more dangerous to make them public. However, constants should usually be public because they're meant to be used and they cannot be modified anyways. There's no point in making us access a method if we can just access it directly, because we can't modify it in any way. And of course, constructors are usually public, but you can have private or other constructors, but they can only be used by other constructors in the same class, which makes sense because everything that accesses it must be in the same class. Or other constructors, you can also call them from other methods in the same class. But anyway, so basically if you make a public constructor, everyone can access it. If you make a private constructor, usually it's only used if you want to construct the object a certain way that you don't want others to do inside of your class. Now, let's go back to our person class again, and let's review inheritance. So basically, student extends person. So first, identify all the instance variables of student. There's grad year and school, obviously, but there's also name, email, phone number, country, and birth year inside of our person class that student inherits automatically. Which are the instance methods? Well, there's display, and that's it. This display method overrides the superclass display method, so whenever I call a display method on a student object, even if it's a person variable, it calls this display method. And super.display again calls the superclass display method, so basically it prints name, email, phone number, country, birth year, then prints graduation year and school. And now the constructors, well, student has only one constructor. Again, it doesn't inherit the person's constructor. You can't construct the student with 5 parameters. you need all 7. The super statement basically just calls the superclass constructor with these 5 parameters. And basically, inheritance can be used for 2 reasons. One, to simplify classes, which we clearly see here, student is simplified, and if we make an employee, it's simplified. So basically, we're pulling our student and employee similarities into a single class so we don't have to write them 2 times, or potentially more times for different types of people. And of course, another reason is that we can have stuff like, let's say, display all, and then we have a person array. For every person, I display it. And now basically, now we can pass a person array, and the person array can contain both persons objects and student objects. And basically, now, for example, display all new person array. Say new person. So down here, name, email, phone number, country, year of birth. Name, email, phone number, country, and year of birth. And again, Java is not space sensitive, so I can space this however I want. And year of birth. And a new student. And we have something like this. And it'll display basically first the person using the person's display method, then the student using the student's display method with the graduation year in school. So that's another use of inheritance. You can like combine objects of different types. If we had an employee class that extended person, we could include that as well. Now let's go over one last big example. So again, so if we wanted a class named point that contains instance variables x and y of type double, and the constructor that sets them, and say get and set methods. So class point represents the point in the plane. Let's make it private, because if we're making get and set methods, we might as well make it private. Have a constructor that sets them. Again, if the constructor parameters name or method parameters name coincides with the instance variable, we need to put this dot to reference the instance variable. Without the this, it's just a parameter. Again, even in the set point method, we need this dot x equals x. So set point double x double y, actually. This dot y equals y. And then let's just say get methods. Now, since methods can take 2 parameters, so therefore we can put both set methods into one. However, methods can only have one return type. So unless you put these 2 variables and return them into an array, which is quite inconvenient, we would probably want 2 get methods. So public double get x, return x, and public double get y, return y. And now let's say we have a class polygon that contains a bunch of points. So point array, let's make it private. Point array points, public polygon, And let's just say that just because we don't want, because if we just set points equals p, then we modify the array outside of this class, then the polygon will also change. We don't want that sometimes. So therefore we can do something like points set to a new array with the same length, and just say for every index points I equals p I, or if we really want to be immutable in that sense, then we can just make it a new point so that no matter what we do to that array or its elements, it's not going to affect this polygon if we do it outside the class. So let's just say new point pi dot get x, pi dot get y. Let's say we have get and set methods. So public void set point int index double x double y. And let's just say I do points index. I could set it to a new point. I could also use its set point method. Doesn't matter because they can't access this element from the point itself anyway. They can only access the x and y. So get point, if we want it to be immutable, I can just return a new point and then say points index dot get x points index dot get y. You can do that. And then I would return a variable of type point. Of course, making it immutable is just to make sure that this thing doesn't have any unforeseen problems. And if you're doing this for yourself, you might not have to do that, as long as you know what you're doing. Now let's go over class rectangle extends polygon. Without these get and set methods, a rectangle that extends polygon might be useless because then we would have no way to access the points. So now, again, we need a constructor. So let's just say point lower left and double length, double width. And then, of course, we need to call super. So in this case, let's just call super with, I need to call it with a new array. So new point array. And then let's just say new point array with lower left. Again, spacing doesn't matter, it just makes it look potentially better. New point lower left dot get x, comma, let's just say the length is in the x direction, so plus length, comma, lower left dot get y, something like that. New point. Again, why do we need to do this rather than just make a bunch of point variables and then do this? Well, it's because we have a super right here. Like, we need to call super as our first statement. That's why. So then lower left dot, say, get x. Basically, we pass in our 4 points. Lower left dot get y plus width. And then new point lower left, so this time the top right, dot get x plus length, and the lower left dot get y plus width. And then this works. And let's just say an area method. Now there's two ways to do this. One is to do it through the points, but that can be annoying. Another way is just to literally keep track of double variables length and width. Of course, this provides a danger, which is that if they directly used a set point or get point method, it might be trouble. But anyway. let's make the length and width variables private. This dot length equals length. This dot width equals width. And then say return length times width. And in fact, if I really don't want them to use their setPoint method, I could do the following. I can override the setPoint method, int index double x double y, and say throw new exception method setPoint int index double x double y is not supported, like something like that, and maybe throws exception. And if we do that, we might want to say this thing, the setPoint method in Polygon also throws exception. Or maybe if we don't want that, we can make this an illegal argument, exception, or some unchecked exception like that. And then it would work. So now basically in our standard Polygon class, we have our we have our array of points, we have our set and get methods. However, in a rectangle that extends Polygon, we fix the 4 points based on a lower left point and a length and a width, which makes it a rectangle. We know the area. We allow the get point method because it doesn't modify the rectangle whatsoever, since we return a new point, not a point in the array, but a point that's identical to a point in the array. And then set point we override so that it's not allowed, say. And then this works. And now, for example, if I have something like rectangle rect equals new rectangle, say new point 3.4, 5.6, and then 7.8, 9.0. Something like that. And then we can print rect.area. We could also get its points. Of course, get a copy of its points. So for example, I can get that. However, this point is a copy. And by that, I ensured that basically if it's a normal polygon, then I get to modify the points, but if it's a rectangle, I don't. Now, suppose we want to be able to print, like, for example, one of these polygons or rectangles. How would we do that? Well, we could make a display method, and we could also make a toString method. A display method is basically you would just call it, and a toString method you can directly print the object or call it and set it to a string. And the good thing about the toString method is that you can modify it using, say, substring combined with pluses to add stuff in between or stuff like that. Meanwhile, if you do the display method, you can't modify it because it's already printed. So we'll do the toString method. For the point, I'll just make an ordered pair. So return the ordered pair. And then for polygon, the toString method would be basically return. So first of all, we would need to return every single point. So string result equals, let's just say I enclose all the points inside brackets. And inside of those brackets, I can do stuff like for something like this. For every point, I basically print the point. So, or actually, not print the point. Since we're returning something, we just add our point to our result. So, result plus equals points I. And note that this is allowed because when a string and an object are combined together, the result is a string. And it uses the object's toString method. Formally, it's the same thing as that. And then afterward, let's just say if I is not equal to the last point, then I do like result plus equals the comma. Because we're supposed to put a comma in between every 2 points, but we don't put a comma after the last point. And the rectangle automatically inherits the toString method from the polygon. So now, for example, if I try to do something like print rectangle, this rectangle, it's gonna print the points successfully. Now, we could also make an equals method. So how do we do that? Well, first, let's make an equals method for point. So public boolean equals another object. So basically, if O is null, return false. If O is not an instance of point, then return false. Then otherwise return, so point P equals point O, and then return X equals P dot X and Y equals P dot Y. And now for the polygon, what about the equals method? So for this one, again, if O is null, return false. If O is not an instance of polygon, then return false. Otherwise, cast it to polygon. And then for this one, when are 2 polygons equal? It's when all their points are equal. So therefore, and let's not worry about the order of points for now. Let's just say they have to be in the same order to be equal, because it's much harder to deal with the ordering. So therefore, basically for every point P1 in, say, or in fact, I can't even do that. So first of all, we have to compare the arrays. So we can't use a for each loop since we're dealing with 2 arrays. And also, since we're comparing arrays, let's first compare the length. So if points.length is not equal to p.length, then return false, because if it's not equal to p.points.length, then return false, because otherwise it doesn't make sense. If they have different number of vertices, then they can't be equal. And notice we can access p.points because it's still inside the polygon class. And now we do a loop with indices because we can't use a for each loop. And basically, if something like points I dot equals points, so p dot points I, if that is not true, then return false. So basically, if any of the points are not equal, it's false. And if we run through the entire loop and that doesn't happen, then I return true, because then they're equal. Every point works. Then therefore, And by the way, the equals method is also inherited by the rectangle. So let's just say I have a polygon, new polygon. Let's just say, for example, we have that. So new polygon with a new point array with that. And of course we need to add new point. We can't just use ordered pairs. We need to use the point constructor. So something like that. So then poly.equals rect would be true because they're the same points, and rect.equals poly would also be true because they have the same points, and rectangle inherits the polygon's equals method. Maybe say if we change this thing to 14.5, then all of a sudden both of them would be false. So equals method works as intended.